Hello, in this lecture we find out the maximum area of a rectangle that is inside the triangle. In the drawing we have triangle ABC. Inside this triangle we have rectangle PQST, and our mission is to find out the maximum area of this rectangle PTSQ. In addition, we know that side AB of triangle ABC equals to 10 units in its length, side AC equals to 17 units in its length, and this is side BC, that is equals to 21 units in its length. I repeat again that our mission is to find out the maximum area of this rectangle PQST that is located inside this triangle ABC. So in the first step, we do a construction. That is to say, from point A, we go perpendicular on PQ. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point A and PQ, this point is point M. In the next step, we extend the perpendicular AM by straight line until it touches side BC of triangle ABC. And we define the touching point of the extended perpendicular AM with side BC. This point is point N. By doing this construction, we created here those two angles. Those two angles are defined as corresponding angles, and they are located between the parallel lines PQ and BC, and therefore they are equal to each other according to the rule that corresponding angles between parallel lines are equal to each other. But this angle equals to 90 degrees according to our construction, therefore this angle must be also equal to 90 degrees. Likewise, we have here those two angles. They are also corresponding angles, and they are located between the same two parallel lines, PQ and BC, and therefore they are equal to each other according to the same rule that corresponding angles between parallel lines are equal to each other. But this angle equals to 90 degrees according to our construction, therefore this angle must be also equal to 90 degrees in its size. In the next step, we will define the length of this line segment BN as x. So, what is the length of line segment NC? From the drawing, it is very easy to see that NC equals to BC minus BN. Again, NC equals to BC minus BN. So, I write it down. NC equals to BC minus BN. So, NC equals to BC is 21 units in itself, according to what is given as the question, minus BN. BN equals to x according to our definition. So in total, NC equals to 21 minus x. So I write it down in the drawing itself. NC equals to 21 minus x units in its length. In the next step, I'll copy this right triangle A and B in a new page, and we will implement the Pythagoras theorem on this right triangle A and B. According to the Pythagoras theorem, in any right triangle, the square of the apertures equals to the sum of the squares of the perpendiculars. Here by PT is the evaluation for Pythagoras theorem. Side BN of triangle ABN equals to x units in its length according to our definition. The hypotenuse AB equals to 10 units according to what is given as the question. So actually, this is the right triangle ABN with the code from the original drawing. According to the Pythagoras theorem, in this right triangle ABN, AB square equals to AN square plus BN square. So I write it down. This will be equation 1. So AB square equals to AN square plus BN square. So here we subtract BN square from this equation, equation 1. And we get that AN square equals to AB square minus BN square. So AN is the missing side, so we leave it as it is. So AN square is equal to AB square. AB is 10, therefore AB square is 10 squared, that is 100. Minus BN square. BN is x, therefore BN square is x squared. So we should find out that according to equation 1, AN square equals to 100 minus x squared. In the next step, I will copy the right triangle ANC in the new page and we will implement the Pythagoras theorem on this right triangle ANC. Here by PT is the relation for Pythagoras theorem. The hypotenuse AC of the right triangle ANC equals to 17 units in its length according to what is given in the question. And we already found out that line side NC equals to 21 minus x. So actually, this is the right triangle ANC that I call it from the original drawing. According to the Pythagoras theorem, in the right triangle ANC, AC square, that is the square of the hypotenuse, must be equal to AN square plus NC square. This is equation 2. Here we subtract NC square from this equation, equation 2. And we get that AN square equals to AC square minus nc squared. Again, an is the missing side, so we leave it as it is. So an squared according to equation 2 equals to AC squared. AC, the product AC is 17, therefore AC squared is 17 squared, that is 289 minus NC squared. NC is 21 minus X, therefore NC squared is 21 minus X squared. So according to equation 2, we should find out that AN squared equals to 289 minus 21 minus X squared. This is according to equation 2. According to equation 1, we have already found out that an squared is equals to 100 minus x squared. So we have here two different equations for the value of an squared. Therefore, we get equation 3 that states that an squared according to equation 1 must be equal to an squared according to equation 2. An squared according to equation 1 equals to 100 minus x squared, and it must be equal to n squared according to equation 2. N squared according to equation 2 equals to 289 minus 21 minus x squared. So according to equation 3, we found out that 100 minus x squared equals to 289 minus 21 minus x squared. We'll open the brackets of this expression 21 minus x squared. We get that according to this equation, equation 3, (100 minus x squared) equals to 289 minus, and 21 minus x squared equals to 21 squared, that is 441, plus x squared minus 2 times 21 times x is minus 42x. So actually, according to equation 3, we found out that (100 minus x squared) equals to 289 minus, inside the brackets we have 441 plus x squared minus 24x. So here we'll open the brackets of this expression, and we get that according to equation 3, 100 minus x squared equals to 289. We have minus before the bracket, so after we open the brackets, we get that this expression will be equal to minus 441 minus x squared, and here we have minus times minus is plus, so minus 42x equals to plus 42x. So here we have minus x squared on both sides of this equation 3, so minus x squared will get cancelled. After we cancel minus x squared, this side of equation 3 we have left only with 100, and the other side of equation 3 we left with 289 minus 441 plus 42x. So here we subtract, we will add 441 to this equation 3, and again that according to this equation 3, 100 plus 441 is 541, and this equals to 289 plus 42x. So here we subtract 289 from this equation 3, and we get that 541 minus 289 is 252, and 252 equals to 42x. So here we divide this equation 3 by 42, and finally we get that according to this equation 3, x equals to 252 over 42 is 6, so x equals to 6 units in its length. In the next step, we return to equation 1. According to equation 1, we also found out that an squared equals to 100 minus x squared. So an squared equals to 100 minus x squared. X is 6, therefore x squared is 6 squared, that is 36. So minus x squared is minus 36. So we shall find out that according to equation 1, an squared equals to 100 minus 36. 100 minus 36 is 64. So we shall find out that according to equation 1, an squared equals to 64. Here we take a root out of this equation, and we get that an equals to the square root of 64, that is 8. So an equals to 8 units in its length. So here we have, actually, this is line segment an, and it is equals to 8 units in its length, so I write it down. An equals to 8 units. In the next step, we will define the width of this rectangle PQST as B. So QS, the width QS equals to B according to our definition. Likewise, we will define the length of this rectangle PQST as A. So here the length PQ equals to A according to our definition, and the width QS of this rectangle PQST equals to B also according to our definition. So PQST is a rectangle, and you know that all the angles inside any rectangle are right angles. Therefore, those two angles, they are both right angles. And this angle equals to 90 degrees. And this angle also equals to 90 degrees because there are two angles inside rectangle PQST. So in the next step, we will focus on this small quadrilateral MQSN. Inside this small quadrilateral MQSN, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, so 270 degrees plus the size of this fourth missing angle, in total they must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, this fourth missing angle must be equal to 90 degrees in its size. So inside this small quadrilateral MQSN, we have 4 right angles. And according to rule 6, any quadrilateral that has 4 right angles must be this rectangle, if not a square. So we relate to this small quadrilateral MQSN as a rectangle because it has 4 right angles. But we also know that the opposite sides of a rectangle are equal to each other. So in the small rectangle MQSN, side QS must be equal to the opposite side MN. But QS is B, therefore MN must be also equal to B. What is the length of this line segment? Line segment AM. From the drawing, it is very easy to see that AM equals to AN minus MN. Again, AM equals to AN minus MN. So I write it down. AM equals to AN minus MN. So AM equals to AN. AN equals to 8. minus Mn. We just found out that Mn equals to B. So in total, AM equals to 8 minus B. So I write it down here that AM equals to 8 minus B. Those two angles, they are defined as corresponding angles and they are located between the parallel lines PQ and BC. And according to the rule that corresponding angles between parallel lines are equal to each other, we get that those two angles must be equal to each other. So if we define this angle as alpha, then this angle must be also equal to alpha because they are equal to each other. Likewise, those two angles, they are also defined as corresponding angles and they are located between the same parallel lines PQ and BC and therefore they are equal to each other according to the same rule. Corresponding angles between parallel lines are equal to each other. So if we define this angle as beta, then this angle must be also equal to beta. In the next step, we prove that the big triangle ABC is similar to the small triangle APQ. And we know that in any similar triangles, the ratio between the heights is equal to the ratio between their sides, or the ratio between the heights, or the ratio between the corresponding heights must be equal to the ratio between their corresponding sides. And therefore, if we implement the rule that I mentioned here, in the two similar triangles A, B, C, and so first of all, we actually have to prove that the big triangle ABC is similar to the small triangle APQ. So why triangle ABC is similar to the small triangle APQ? First of all, those two angles are both equal to alpha and therefore they are equal to each other. In addition, those two angles are both equal to beta and therefore they are equal to each other. And finally, this is angle A, that is a common angle, it belongs to both triangles. Therefore, we can write down that angle A equals to itself as a common angle that belongs to both triangles. So actually found out that all the three angles of the big triangle ABC are correspondingly equal to all the three angles of this small triangle APQ. And therefore triangle ABC is similar to the small triangle APQ according to angle similarity rule. And as I already mentioned 1 minute ago, whenever you have two similar triangles, then the ratio between their heights must be equal to the ratio between their sides. So in the two similar triangles, triangle ABC and triangle APQ, it means that the height AM in the small triangle APQ over the height AN in the big triangle ABC. So here, AM over AM is the ratio between the heights of the two similar triangles ABC and APQ. So the ratio between the heights must be equal to the ratio between their sides. And the ratio between their sides is side PQ of the small triangle APQ over side BC of the big triangle ABC. So she found out that what is the meaning of equation 1? The meaning of equation 1 is that the ratio between the heights of the two similar triangles, that's AM over AN, must be equal to the ratio between their corresponding sides, that is actually PQ over BC. Okay? So this is equation 1 is the implementation of the rule that in two similar triangles, the ratio between Their height must be equal to the ratio between their sides. What is the length of AM? AM equals to 8 minus B over AN. AN equals to 8. What is the length of PQ? PQ equals to A according to our definition. So we substitute PQ by A over BC. BC equals to 21 units in its length according to what is given in the question. So actually found out that according to equation 1, 8 minus B over 8 equals to A over 21. So here we cross multiply this equation, equation 1, and we get that 8 times A equals to 21 times 8 minus B. So here we divide this equation 1 by 8, and we get that A equals to 21 over 8 times 8 minus B. So here we open the brackets on this side of this equation 1, and we get that A equals to 21 times 8 over 8 is 21, of course. And here 21 over 8 times minus B equals to minus 21B over 8. So here we will multiply this equation 1 by B, and finally we get that according to this equation 1, A times B equals to 21B, and minus 21B over 8 times B is minus 21B squared over 8. So according to equation 1, A times B equals to 21B minus 21B squared over 8. What is A times B? A is the length of this rectangle PQST, and B is the width. And the length times the width is the area of this rectangle PQST. So actually found out that the area of rectangle PQST, because A times B is the area, equals to 21B minus 21B squared over 8. So the area, we have here the area of rectangle PQST as function of B. Repeat again, we have the area of rectangle PQST as function of B. B is the independent variable because we can substitute B for any positive value that we would like, and after we determine the value of B, then the value of the area, that is A times B, will be determined immediately. So B is the independent variable and the area is the dependent variable. And our mission is to find out the maximum area of this rectangle PQST. And the area is AB. So our mission is to find out the maximum value of A times B of rectangle PQST, or for which B, the area A times B will get its maximum value. So in order to find out what is the maximum value of A times B in this equation 1, we have to differentiate this function area and equate its derivative to 0. Again, in order to find out the maximum value of a times b, we have to differentiate this function area and equate its derivative to 0. By differentiating this function area and equating its derivative to 0, we will find out the extreme point of this function area of rectangle PQST. And then we have to determine whether if the extreme point that we found is the minimum extreme point or a maximum extreme point. And in order to answer on that question, we have to draw the graph of the function area, and from the graph we can easily determine whether the extreme point that we found is the maximum extreme point or a minimum extreme point. So in the first step, we will differentiate the function area of rectangle PQST. So here we take the derivative of this function area of rectangle PQST. So D is the version for the derivative, so we take the derivative of the area of rectangle PQST. It's actually equals to 21b minus 21b squared over 8. And we take the derivative according to the variable, the independent variable b. This expression means that we take the derivative of this expression according to the variable b, and then we equate the derivative to 0. So by differentiating the function area and equating its derivative to 0, we find out the extreme points of the function area, and then we draw the graph of the function area to determine whether if the extreme point that we found is a minimum extreme point or a maximum extreme point. Of course, that we are interested in the maximum extreme point, because we have to find out the maximum value of this rectangle PQ, the maximum value of this rectangle PQST. This is actually the maximum value of a times b, that is the area of rectangle PQST. So what is the derivative of 21b? Actually, the derivative of b is 1. Therefore, in total, the derivative of 21b will be equal to 21 times 1, that is 21. And what is the derivative of minus 21 over 8 times b squared? Actually, we know that the derivative of b squared is 2b, so in total, the derivative of this expression will be equal to minus 21 over 8 times 2b, and it is equals to 0. So here we take 21 as a common factor from those two expressions. So what is left? 21. What is left from 21 after we took from it 21 as a common factor? What is left is actually 1. And what is left from this expression after we took from it 21 as a common factor? What is left is actually minus 2b over 8, and it equals to 0. So here we divide this equation 2 by 21, and you get that according to this equation 2, 21 over 21 is 1, so in this side of the equation we left only with 1 minus 2b over 8, and in the other side of the equation we have 0 over 21 is 0. So actually, according to equation 2, we found out that one minus 2b over 8 equals to 0. Here we add to this equation 2, 2b over 8, and we get that 1 equals to 2b over 8. So according to equation 2, 1 equals to, here we will divide both the numerator and the denominator of this expression by 2. So 2b over 2 is b, and 8 over 2 is 4. So actually found out that according to equation 2, 1 equals to b over 4. Here we multiply this equation 2 by 4, and finally we get that for the first question 2, B equals to 4 units in its length. So actually found out that the extreme point of this function area of again PQST, the extreme point is B equals to 4. In the next step, we have to draw the graph of this function area in order to determine whether if the extreme point B equals to 4 is a minimum extreme point or a maximum extreme point. I already drew the function area, the graph of the function area of rectangle PQST. That is the graph of the area of rectangle PQST is function of the width B. So in the y-axis we have the area, in the x-axis we have the width B. And from the graph it is very easy to see that when B equals to 4, B is the extreme point that we found. When B equals to 4, then the area gets its maximum value. And the maximum value is a little bit greater than 40 square units. This number is 40. So in this way we found out that the extreme point B equals to 4 that we found is indeed maximum extreme point and not a minimum extreme point. So the only thing that we have to do is to put the value B equals to 4 inside the function area in order to find out what is the maximum area of rectangle PQST, because we know that B equals to 4 is indeed maximum extreme point. So the area function of rectangle PQST is A times B. A times B is the area, and the area equals to 21B minus 21 over 8 times B squared. And we just have to substitute B by 4 because B is the maximum extreme point. So the maximum area of rectangle PQST is A times B, and it is equals to 21B. B is 4, therefore 21B is 21 times 4, minus, here we have B squared. B is 4, therefore B squared is 4 squared, that is 16. So in total, the value of this expression equals to 16 over 8, that is 2, and 2 times minus 21 is minus 42. So if we found out that the maximum area of rectangle PQST is 21 times 4, that is 84, and 84 minus 42 is 42. So the maximum area of rectangle PQST is equals to 42 square units. And the answer to the question is that the maximum area of this rectangle PQST that is located inside this triangle ABC is equals to 42 square units. So now we will find out also what is the length of this rectangle PQST when the area is 42. We know that the width B is 4. So what is the length of this rectangle PQST when the width B equals to 4? We have a question 1 that states that the length A equals to 21 minus 21 over 8 times B. We just have to substitute B by 4, and this way we find out what is the length A. So the area, the length A equals to 21 minus 21 over 8 times B is 4. So the length equals to 21 minus, here we have 4, we divide both the denominator and the denominator of this expression by 4, so 4 over 4 is 4, so in the denominator we left only with minus 21, and here we have 8 over 4 is 2. So the length A equals to 21 minus 21 over 2. Minus 21 over 2 is minus 10.5. So the length A equals to 21 minus 10.5, that is 10.5 units. So actually found out that when the width of rectangle PQST equals to 4 and the length A equals to 10.5 units, then the area is A times B. That's actually A is 10.5 times B is 4, and 10.5 times 4 is 42. So in conclusion, actually found out that when the maximum area of this rectangle PQST is 42 square units, and when the maximum area of this rectangle PQST is 42 square units, then its width is 4 and its length is 10.5, and 4 times 10.5 is of course equals to 42 square units. Okay, thank you very much. So in the next step, I'll summarize the lecture. In this lecture, I found out the maximum area of this rectangle PQST that is located inside this triangle ABC. Okay, so we know that in the drawing we have triangle ABC. Inside this triangle ABC we have this rectangle PQST. In addition, you know that side AB of triangle ABC equals to 10 units in its length, side AC equals to 17 units in its length, and side BC of this triangle ABC equals to 21 units in its length. Again, our mission is to find out the maximum area of this rectangle PQST that is located inside this triangle ABC. So in the first step, we did the construction. That is to say, from point A, we drew perpendicular on PQ. Again, from point A, we drew perpendicular on PQ. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point A in PQ. This point is point M. In the next step, we extended the perpendicular AN by a straight line until it touches side BC of this triangle ABC. And we define the touching point of the extended perpendicular AN with side BC. This point is N. By doing this construction, we can add here those two angles. Those two angles are defined as corresponding angles, and they are located between the two parallel lines PQ and BC, and therefore they are equal to each other according to the rule that corresponding angles between parallel lines are equal to each other. But this angle equals to 90 degrees according to our construction, therefore this angle must be also equal to 90 degrees. Likewise, those two angles are also defined as corresponding angles, and they are located between the same two parallel lines PQ and BC, and according to the same rule that I mentioned, that corresponding angles between parallel lines are equal to each other, those two angles must be equal to each other. But this angle equals to 90 degrees according to our construction, therefore this angle must be also equal to 90 degrees in its size. Okay, so in the next step we defined the length of this line segment BN as X. So what is the length of line segment NC? the length of line segment NC equals to BC minus BN. I'll repeat again. If NC equals to BC minus BN. So NC equals to BC, that is 21, according to what is given in the question, minus BN, that is X according to our definition. So in total, NC equals to 21 minus X units in its length. Okay. In the next step, I copied the right triangle A and B. In the new page, we implemented the Pythagoras theorem on this right triangle, triangle A and B. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. In this right triangle A and B, the hypotenuse is AB, therefore the square of the hypotenuse is AB square, and it must be equal to AN square plus BN square. Repeat again, according to equation 1, AB square equals to AN square plus B square plus BN square. Here we subtract BN square from this equation, equation 1, and found out that AN square equals to AB square minus BN square. So AN is the missing side, so we leave this it is. So AN square equals to AB square. AB is 10, therefore B square is 10 squared, that is 100 minus BN square. BN is X, therefore BN square is X squared. So in total, according to equation 1, we found out that AN square equals to 100 minus X squared. In the next step, I copied this right triangle, triangle NC in a new page, and implemented the Pythagoras theorem in this right triangle, triangle NC. Actually, this is the right triangle, triangle ANC that I copied from the original drawing. The hypotenuse AC equals to 17 in its length, according to what is given as the question. We have already found out that the side NC equals to 21 minus X, so according to the Pythagoras theorem, in this triangle, triangle NC, AC square equals to AN square plus NC square. Again, AC square equals to AN square plus NC square. Here we subtracted NC square from this equation, equation 2, and found out that AN square equals to AC square minus NC square. So AN is the missing side, so we leave this it is. AN square equals to AC square. AC is 17, therefore AC square is 17 square, that is 289 minus NC square. NC is 21 minus X, therefore NC square is 21 minus X square. So according to question 2, we found out that AN square equals to 289 minus 21 minus X square. This is according to equation 2, and according to equation 1, we have already found out that AN square equals to 100 minus X square. So we have two different equations for the value of AN square. Therefore, we get equation 3 that says that AN square according to equation 1 must be equal to AN square according to equation 2. AN square according to equation 1 equals to 100 minus X square. And this is equal to AN square according to equation 2. This is equal to 289 minus 21 minus X square. Here we open the brackets. So in total, according to equation 3, we found out that 100 minus X square equals to 289 minus 21 minus X square. Here we open the brackets of this expression, 21 minus X square, and found out actually that 100 minus X square equals to 289 minus and 21 minus X square equals to 21 squared, that is 441, plus X square minus 2 times 21 times X is minus 42X. The next step, we open the brackets of this expression and found out actually that according to equation 3, 100 minus X square equals to 289, and we have minus before the brackets, so this expression after we open the brackets will be equal to minus 441 minus X square, and we have minus times minus is plus, so minus 42x is plus 42x. So here we have x squared on both sides of the equation 3. Therefore x squared we get minus x squared we get cancelled. After we cancelled minus x squared, in this side of equation 3 we left only 100. On the other side of equation 3 we left with 289 minus 441 minus 441 plus 42x. Here we added 441 to this equation, equation 3, finally found out that 441 plus 100 is 541, and 541 equals to 289 plus 42x. Here we subtract 289 from this equation, equation 3, and finally found out that 541 minus 289 is 252, so 252 equals to 42x according to this equation, equation 3. Here we divided this equation 3 by 42 and finally found out that x equals to 252 over 42 is 6. So x equals to 6 units in its length. We turn to equation 1. According to equation 1, we already found out that an squared equals to 100 minus x squared. So an squared equals to 100 minus x squared. X is 6, therefore x squared is 6 squared, it is 36. So in total, we found out that an squared equals to 100 minus 36. 100 minus 36 is 64. So we found out that according to equation 1, an squared equals to 64. Here we took a root out of this equation and finally found out that an equals to the square root of 64, that is 8. So here an equals to 8 units in its length. An equals to 8 units in its length. Here I wrote it here that an equals to 8 units. In the next step, we define the length of this rectangle PQST as B, so the width is B. The width of this rectangle PQST is B, so the width QS equals to B according to our definition. Likewise, we define the length of this rectangle PQST as A, so the length PQ equals to A according to our definition, and the width QS equals to B also according to our definition. We know that all the angles inside the rectangle are right angles. So those two angles that are inside rectangle PQST, they both must be equal to 90 degrees. In the next step, we focus on this small quadrilateral MQSN. Inside this small quadrilateral MQSN, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, so 270 degrees plus the size of this fourth missing angle. In total, they must be equal to 360 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, this fourth missing angle must be equal to 90 degrees in its size. So inside the small quadrilateral MQSN, we have 4 right angles, and according to rule 6, any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we have to this quadrilateral MQSN is a rectangle because it has 4 right angles. But we also know that the opposite sides of the rectangle are equal to each other. So the rectangle in the small rectangle MQSN, side QS must be equal to the opposite side MN, but QS equals to B according to our definition. Therefore, MN must be also equal to B. So what is the length of line segment AM? Line segment AM equals to AN minus MN. Again, AM equals to AN minus NM. So AM equals to AN, that is 8, minus MN, that is B. So in total, we found out that the length of this line segment AM is 8 minus B. In the next step, we proved that the big triangle, but before that, we know that those two angles are both defined as corresponding angles, and they are located between the two parallel lines PQ and BC, and therefore they are equal to each other according to the rule that the corresponding angles between parallel lines are equal to each other. So if you define this angle as alpha, then the other angle must be also equal to alpha because they are equal to each other. Likewise, those two angles are also defined as corresponding angles, and they are located between the same two parallel lines PQ and BC, and therefore they must be equal to each other according to the same rule that the corresponding angles between parallel lines are equal to each other. So if this angle is beta, then the other angle, this angle must be also equal to beta because those two angles are equal to each other according to the rule that I mentioned. In the next step, we proved that the big triangle ABC is similar to the small triangle APQ. So why is the big triangle ABC similar to the small triangle APQ? First of all, those two angles are both equal to alpha, therefore they are equal to each other. In addition, those two angles are both equal to beta, and therefore they are equal to each other. And finally, this is angle A, that is a common angle, it belongs to both triangles, so we can write down that angle A equals to itself as a common angle that belongs to both triangles. So actually proved that all the angles of the big triangle ABC are correspondingly equal to all the angles of the small triangle APQ, and therefore the big triangle ABC is similar to the small triangle APQ according to angle similarity rule. And from the facts, and whenever you have two similar triangles, then the ratio between their heights must be equal to the ratio between their sides. In this two similar triangles ABC and APQ, it means that side AM in the small triangle APQ or side AM in the big triangle, the height AM in the small triangle APQ over the height AN in the big triangle ABC must be equal to the side PQ of the small triangle APQ over the side BC of the big triangle, triangle ABC. Repeat again. Equation 1 means that the ratio between the heights of the two similar triangles must be equal to the ratio between their sides. The ratio between their heights is AM over AN, and must be equal to the ratio between their sides. This is actually PQ over BC. AM is 8 minus B, AN is 8, PQ is 8, BC is 21. So in conclusion, according to equation 1, we found out actually that 8 minus B over 8 equals to A over 21. Here, of course, multiplying this equation in equation 1, and finally found out that 8 times A equals to 21 times 8 minus B. Here we open the brackets on this side of this equation, equation 1, but before that we divided this equation, equation 1 by 8, and finally found out that A equals to 21 over 8 times 8 minus B. Here we open the brackets on this side of this equation, equation 1, and finally found out that A equals to 21 times 8 over 8 is 21, and 21 over 8 times minus B is minus 21 over 8 times minus B. So according to equation 1, we found out that A equals to 21 minus 21 over 8 times B. Here we multiply this equation, equation 1 by B, and finally found out that according to this equation, equation 1, A times B equals to 21B minus 21B squared over 8. But what is A times B? A is the length of this rectangle PQST, and B is the width. And the length times the width is the area of this rectangle PQST. So in equation 1 we have the area AB of rectangle PQST equals to 21B minus 21B squared over 8. Okay? And our mission is to find out the maximum area of this rectangle PQST. In other words, our mission is to find out the maximum value of A times B, because A times B is the area of rectangle PQST, or for which B, the value of A times B, that is the area of rectangle PQST, for which B, A times B will get its maximum value. For which B, the area of rectangle PQST that is A times B will get its maximum value. In order to answer that question, we have to differentiate the area and the function area of rectangle PQST and equate its derivative to 0. In this way, we find out extreme points of this function area, and then in order to determine whether if the extreme point that we found is a minimum extreme point or maximum extreme point, we have to draw the graph of the function area, and from the graph we can determine if the extreme point that we found is a minimum extreme point or a maximum extreme point. So in the first step, we actually differentiated this function area of the rectangle PQST. So we took the derivative, this version for derivative of the function area of rectangle PQST. And the function area is 21b minus 21b squared over 8, and we equated the derivative to 0. And we took the derivative according to the variable b, the independent variable b. Okay? So what is the derivative of 21b? The derivative of b is 1, so in total the derivative of 21b is 21 times 1, that is 21. And what is the derivative of minus 21 over 8 times b squared? Actually, the derivative of b squared is 2b, so in total the derivative of this expression will be equal to minus 21 over 8 times 2b, and we equated this derivative to 0. Then we took 21 a second factor out of those two expressions. So what is that from 21 after we took from it 21 a second factor? What is that? It's actually 1. And what is left from this expression after we took from it 21 a second factor? What is left is actually minus 2b over 8. And if it is equals to 0. Here we divided this equation 2 by 21, and found out actually that 21 over 21 is 1. So in this side of the equation we left only with 1 minus 2b over 8. And here 0 over 21 is 0. So after we divided equation 2 by 21, we found out actually that according to equation 2, 1 minus 2b over 8 equals to 0. Then we added 21 over b, we added 2b over 8 to this equation, equation 2, and finally found out that 1 equals to 2b over 8. Here we divided both the numerator and the denominator of this expression by 2. So 2b over 2 is b and 8 over 2 is 4. So in total actually found out that according to equation 2, 1 equals to b over 4. Here we multiply this equation 2 by 4 and finally found out that according to equation 2, b equals to 4 units instead. So actually we found out that the extreme point of this function area of rectangle PQST is b equals to 4. Now we have to determine whether the extreme point b equals to 4 is a minimum extreme point or maximum extreme point. In order to determine it, we actually draw the function area of this of rectangle PQST. This function area of rectangle PQST. Actually, this is the function area of rectangle PQST. In the y-axis we have the area, that is a times b, and in the x-axis we have the width b. And from the graph of the function area of rectangle PQST, it is very easy to see that when the width b equals to 4, then the area gets its maximum value, that is a little bit greater than 40 square units. And therefore, actually, the extreme point b equals to 4 that we found is indeed a maximum extreme point and not a minimum extreme point. The only thing that is left to do is to put the value of b equals to 4 inside the function area in order to find out what is exactly the maximum area of rectangle PQST when b equals to 4. Okay. So again, the function area of rectangle PQST is a times b. A times b is the area, and the area equals to 21b minus 21 over 8 times b squared. We just have to substitute b by 4 in order to find out what is the maximum area of rectangle PQST. And we found out actually that the maximum area, that is a times b, equals to 21 times b. b is 4, so it is 21 times 4. And here we have minus 21 over 8 times b squared. b is 4, therefore b squared is 4 squared, that is 16. Here. And here we have 16, and 16 over 8 is 2. So in total, this expression equals to 2 minus 21, that is minus 42. So in total, the maximum area of rectangle PQST equals to 21 minus 4, 21 times 4 minus 42. 21 times 4 is 84, and 84 minus 42 is 42. So actually found out that the maximum area of this rectangle PQST that is located inside this triangle ABC is equals to 42 square units. And we know that in the maximum area of rectangle PQST is 42 square units, then the width B is 4. What is the length A? We can find out the length A according to equation 1 that says that A equals to 21 minus 21 over 8 times B. We just have to substitute B by 4. We did it and found out actually that the length A equals to 21 minus 21 over 8 times B. B is 4. So here we have minus 21 times 4 over 8. Here we divided both the numerator and the denominator of this expression by 4. 4 over 4 is 1, so in the numerator we left only minus 21. In the denominator we have 8. 8 over 4 is 2. So in total, this expression equals to minus 21 over 2. And therefore, the length A equals to 21 minus 21 over 2. Minus 21 over 2 is minus 10.5. Therefore, the length A equals to 21 minus 10.5, that is 10.5. So actually found out that when the width B of rectangle PQST is 4 and the length A is 10.5, then the maximum area is A times B. A is 10.5, B is 4, and 10.5 times 4 is 42 square units. Repeat again. We shall find out that the maximum area of this rectangle PQST that is located inside this rectangle, and the maximum area of rectangle PQST that is located inside this triangle ABC is equals to 42 square units. Okay, thank you very much.